Identify the vertex, focus, axis of symmetry, and directrix of this guy right here. Then I have to sketch the graph. All right, I have a y that's not squared and an x inside of a parentheses that is squared, which tells me it is a parabola. Now, what is all this other stuff? Well, if I were to draw just some random parabola right there, focus lives inside the curved part of the parabola. That's the focus. The vertex is the minimum or maximum, and then equally distant is going to be a flat line called the directrix. Okay? Now I'm going to have to draw all this stuff out at some point. Not quite yet. Let's just focus on one thing at a time and finding stuff out. The x part is squared. There are parabolas where the y part is squared, so make sure when you're looking for the formula that you compare this to, you use the right one. This is the standard form of a parabola where the x part is the one that's squared. X minus h in parentheses squared is going to equal 4p, and if you're like, p, what does that stand for? You'll find out. Y minus k. I need to make that look like that. So what I'm going to do first is I am going to flip things. Let's just completely flip everything. We've got negative x plus 3 squared. I'm actually going to I'm going to still flip it. Minus 1 is going to equal to y. Okay, now what I need to do is I need to get all the y stuff on the right side. So let's add 1. So negative x plus 3 squared. Let's add 1 to both sides. So now I have y plus 1. Let's throw a parentheses around that just for funsies. And let's multiply both sides by a negative. So what we have is x plus 3 squared equals negative. And I'll put negative 1 even though I don't need to. I'm multiplying everything by a negative. There you have it. Now I can compare that to that. It's important to know that I have to find the vertex, the focus, and the axis of symmetry, and the directrix. Okay, well, the vertex is going to be HK. So the vertex in this case is going to be h. Now, negative h is positive 3 here, which means positive h is negative 3. So h is negative 3. K, similarly, positive 1 is negative k. So positive k is going to be negative 1. Okay, that's my vertex. Let's get a different color. My focus is found by taking h and then k plus p. You might be thinking, what's p? I still have to figure that out. In front of the parentheses here, I have 4p, and this is negative 1. So comparing this to this, I'm going to let 4p equal negative 1. So if I divide both sides by 4, p is negative 1/4. So my focus is h, and I already know that my h is negative 3. K plus p is going to be negative 1 plus negative 1/4, so negative 1 1/4. All right, so what I have so far, and let's circle things out, is my vertex is there. My focus is there. My axis of symmetry is going to be a vertical line that cuts through the vertex. So my axis of symmetry, since it's going to be a vertical line, is going to be x equals. Well, if it cuts through the vertex, then x equals right there, negative 3. So that is my axis of symmetry. Last but not least, my directrix is going to be a horizontal equation given to us by y equals k minus p. K was negative 1. P is negative 1/4. So to round things out, y equals negative 1 minus negative 1/4 is the same as negative 1 plus 1/4 which is going to be negative 3/4. Now I know I'm going to do a terrible job drawing this out. Okay, I'm going to do a terrible job. So what I'm going to do is I'm going to paste the picture that I'm supposed to have. Did it work? Did it work? I don't think it worked. I don't think it worked. Let's try it again. Copy, paste, and it didn't work. All right, let's try it this way. Let's try copying it like this. This makes for very good podcasting. All right, I captured it. Let's go back over here. There we go. All right. So, why is it upside down? Because this is negative. That's thing number one. Okay, let's label this picture a little bit. My vertex is negative 3, negative 1. So my vertex, my vertex does live right there. Okay, my directrix right here is y equals negative 3/. So it's like a little dashed line, like kind of like right there, whereas my focus is negative 3, negative 1 1/4 lives right there. Okay, so we can kind of see everything falling into place. My axis of symmetry is x equals negative 3. So there's my vertical line that goes through negative 3. So we can see everything there, directrix, axis of symmetry, focus right there, vertex right there. So everything lives where it should be. And if you're wondering, well, how can I get points to make a graph? Just plug random points in. If you know what your vertex is and it's negative 3, negative 1, then plug in negative 2 and see what y value you get. Plug in negative 1 and see what y value you get. And whatever you start graphing over here, the same exact thing is going to happen over here because this acts as a mirror image. So graphing parabolas when they're in this standard form is never fun, but we did it, and I had a great time. Parabolas. Identify the vertex, focus, axis of symmetry, and directrix, then sketch the graph. First things first, we need to realize that this is a parabola because one of my x thingies is squared and one of my x thingies is not. Okay. But this is different because it's the y thingy that's squared and the x thingy that's not. So this is going to open sideways, and we have to figure out which ways that sideways is going to go. So I'm going to compare this to y minus k. This is the standard form for a sideways opening parabola. That's going to equal 4p times the quantity x minus h. So I need to make this look like that. Okay, so first thing I want to do is swap this. So I have y plus 5 squared equals negative 1/3 x minus 3 not squared. And now it's exactly the way I need it to look like. Okay, all is well. Let's compare the two. Okay. Y plus 5 squared, y minus k squared. Negative k is positive 5, so k is negative 5. Okay, x minus 3, x minus h. Negative h is negative 3, so h is positive 3. And if negative 1/3 is the same as 4p, then what I do is I say 4p equals negative 1/3. Divide both sides by 4, and p is negative 1/12. Now I have all the information that I need. Okay, we find our vertex by doing hk. In this case, hk is 3, negative 5. That's our vertex. That's thing number one. We find our focus, in this case, by doing h plus p k. So h is 3 plus 1/12 is going to be 2 and 11/12. My k doesn't change. K is negative 5. My directrix is x equals h minus p. Now, x equals means it's a up and down line, which is what tells me it's sideways. So what do I have? H is 3 minus negative 1/12. So 3 plus 12, x is equal to 3 and 1/12. Okay, that's my directrix. And my axis of symmetry in this case is y equals a vertical line that goes through my axis of symmetry. My axis of symmetry is 3, negative 5. If it's y equals, then y is that negative 5. Okay, so there's my axis of symmetry. There is my directrix. There is my focus. And there is my vertex. So a quick look at this. All right, now I'm not even going to pretend like I can sketch this. I'm not going to sketch this. This opens sideways and to the left. How do I know that? Well, my directrix, and this is just going to be a rough draft, since my directrix lives to the right of my vertex, that has to open to the left, and my focus is always going to live inside. Okay, so let me actually pull up a picture that I stole from Desmos of what it should look like. There you have it. And we can see everything kind of falling into place. Okay, even though things are kind of close to each other, we can see that our vertex is 3, negative 5. So right 3, down 5, there's our vertex. And so where you can barely see it, our directrix is going to be just to the right of it as a dashed line, just to the right of it. And then our focus is just to the left of it. And you can see that our axis of symmetry is y equals negative 5, which goes through it. So the picture is good. And if you're like, well, how do I graph it completely? Well, then you take points, knowing what your vertex is, you take possible y values, plug them in, and see what x value you get, and then that gives you more points to draw. But this gives me a sketch. This is what it ends up looking like, and yeah, not so bad. Not so good, but not so bad. Use the information provided to write the transformational form equation. All right, so what do we have here? We have a vertex. We have a focus. This is a parabola. Okay, this is a parabola, and what we see here is that the focus lives to the left of the vertex. So we have an equation that looks like this. An equation of a parabola that looks like that in standard form is going to be y minus k squared equals 4p times the quantity x minus h. Now let's label some things. The vertex is hk. The focus is going to be h plus pk. So I have an h, not bad. I have a k, not bad. I don't have a p, so let's find out what that is. H plus p is going to equal negative 17/16. H is negative 1. So let's replace that. H is negative 1. Add 1, and P is now going to be negative 1/16. So let's put all this together. Let's rewrite this equation and substitute what we just found out. Y minus k is y double negative k squared equals 4 times p. P is negative 1/16 times x minus h, which is negative 1, another double negative. So let's clean this up and put our answer down here. y minus negative k. Why did I say k when I know that it's negative 3? What a rascal I can be sometimes. Y minus negative 3 is y plus 3 squared equals 4 times negative 1 over 6 is negative 1/4. And then x double negative 1 is x plus 1. So there you have it. There you have it. Parabola, baby. Identify the center, radius, and sketch. All right, so this is a circle because it mentions radius. Radii only live with circles, so that is the circle formula. This is the circle formula right here, actually. X minus x minus h squared plus y minus k squared is going to equal r squared. This is actually pretty easy. If negative, now my center, I'm jumping ahead. My center is hk. Negative h is positive 3, which means positive h is negative 3, so that's the x value of my center. Negative 6 is positive 4, so positive 6 is negative 4. There's my center. Now I need a radius. My radius squared is equal to 5. So if I square root both sides, my radius is going to be whatever the square root of 5 is, and that's 2.2 blah, 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 blah. Now, I'm not even going to try to draw this out, except that I am going to try to draw this out. Let's place my center at negative 3, negative 4. And then I try to draw out and around 2.2 units. So this is what the outside would look like. And then I would draw that picture around. Oh my gosh, I'm actually doing it. That's not bad. That's not bad. Here's what it's supposed to look like. Oh my gosh. Well, I mean, it's not perfect, but that's probably the best circle that I can whip up. But there you have it. So given all the information that we have, you could see, where my center is at negative 3, negative 4, and then a circle that's a little more than 2 around it. So yeah, I'll give myself a pat on the back. Do you hear that sound? That's me patting myself on the back. All right, we graphed a circle, boys and girls. Fun. Identify the center, radius, and then we're going to sketch this out. Now, if you're looking at this and thinking, what the heck is this? Well, it mentioned radius, which tells us it's a circle. Now, a circle is supposed to look like something with an x in it squared plus something with a y in it squared equals some number. I need to make this look like that. So let's group all the x's together, x squared and 4x, and let's purposely leave ourselves some space. And then let's group the y's together. So y squared, 2y, let's leave some space. And while we're at it, why don't we add 4 to both sides? Now what I'm going to do is I'm going to use completing the square twice to make this look like that. In order to complete the square for this part right here, I take half of the number in front of x, 2, square that, 4, and add that to both sides, like so. I'm going to do the same thing right here. Take half of 2, 1, square that, 1, and add that to both sides. Now, what this leaves me with is this guy right here ends up being x plus 2 squared because now it's a perfect square trinomial. This guy right here ends up being y plus 1 squared because that's a perfect square trinomial. And this guy ends up being 9 because 4 plus 1 is 9. Now I compare this to the equation of a circle, which is x minus h squared plus y minus k squared equals r squared. My center is HK. So if negative h is positive 2, then positive h is negative 2. And if negative k is positive 1, then positive k is negative 1. There's my center. My radius is r squared equals 9. So if I square root that, r equals 3. I'm going to try to draw this out. So my center is going to be at negative 2, negative 1. Since that's a pretty number, drawing this out shouldn't be too bad. So a radius going to the right gets me an outside right there. A radius going up 1, 2, 3 gets me right there. A radius going to the left 1, 2, 3 gets me right there. And a radius going down, down gets me right there. And then we try to draw a circle which looks like that, and I'm extremely pleased. I don't think I can do a better job if I was paid to do a better job, which I'm barely paid at all because I'm a math teacher. But that's our guy. We just graphed a circle of something that's not even close to resembling standard form. Good work, everybody. Use the information provided to write the standard form equation of a circle. Well, the standard form equation of a circle is x minus h squared plus y minus k squared equals r squared. My center is hk. Well, that's nice. There's my h, there's my k. My r is, I don't know. But you know what I do know? That the area of a circle is pi r squared. So the area of my circle is 16 pi. So 16 pi is equal to pi r squared. And those pi's are useless because we can divide both sides by pi. If I take the square root of that, r is going to equal 4. Oh, so let's put all of this together, shall we? X minus h is x minus 15 squared, plus sign. Y minus k is y minus negative 8, a double negative. We'll deal with that in a second. And r squared is 4 squared, which is a fun game. By the way, we already found out that r squared was 16 a minute ago. Maybe I could have kept it like that, but, who cares? X minus 15 squared plus y double negative is a positive 8 squared equals 16. That is a radius in standard form with a center of 15, negative 8, and an area of 16 pi, baby. Fun. Identify the center, vertices, co-vertices, and foci, and then sketch the graph. All right, what do we have? We have an ellipse. I know it's an ellipse because the x part's squared, the y part is squared. That's a plus sign and it's equal to 1. If it's a minus sign, then it's not an ellipse. You'll learn that in a future video. But what I also see is the part underneath x squared is larger than the denominator underneath y squared, which tells me that the ellipse is going to have a major axis that's wider and is also horizontal. So I need to compare this guy to this guy. X minus h squared over a plus y minus k squared over b. And that's going to equal 1. Actually, a is squared and b is squared, silly me. Now, if you're looking at this and saying, what if 16 was under y squared? That's a different equation. And that's a different animal all in itself. So, the center is found by doing hk. If h is negative here, and negative h is positive 3, then my center is going to be negative 3 because positive h is negative 3. Similarly, but opposite literally, if negative k is negative 1, then k is positive 1. That's my center. My vertices are given by h plus or minus a and k. Now, 16 is a squared, which means a is the square root of that, 4. So I have two vertices here, h plus 4 or negative 3 plus 4, which is 1. K doesn't change. And my other vertex is going to be h minus 4 or negative 3 minus 4, which is negative 7, and then k is 1 still. So these are my vertices. My co-vertices are found by using negative h and k plus or minus b. All right, negative, did I say negative h? Regular h. Oh, man, let's try to get rid of that. Sorry, everybody. Regular h. All right, h is negative 3. I can handle that. So let's write them both out. Negative 3. K is 1. If b squared is 4, then the square root of 4 is going to be b, so 2. So I have 1 minus 2, which is negative 1, and 1 plus 2, which is regular 3. Those are my covertices. Now, the way I find my focus is I need to come up with a C, and the way you find a C, and I'm looking at what color I didn't use, red. The way you find a C for your focus is going to be c squared minus or equals a squared minus b squared. Now I know that a squared is 16. So c squared equals 16 minus b squared, which is 4. 16 minus 4 is 12. And the square root of 12 is going to be somewhere along the lines of 3.5. My focus is going to be h plus or minus c and k. So that's going to become negative 3 plus 3.5-ish is going to be 0.5-ish. K is 1. And then my other focus is going to be what was it? Was it negative 3 minus 3.5, which was negative 6.5-ish, 1. So drawing this out, probably not going to go well for me, but I'm going to give it a shot. I'm going to give it a shot using the colors that I have. So let's start out with the best part, which is the center, negative 3, 1. Negative 3, 1. There's my center. My vertices are 1, 1. So 1, 1. And negative 7, 1 right there. So that represents the sides of it. My co-vertices are negative 3, negative 1, and negative 3, positive 3. And then my foci just kind of are invisible dots that live on the inside, which is going to happen at here-ish and here-ish. They don't do anything or have anything to do with the drawing of my picture. And yes, I said drawing. So let's try to connect these dots the best I can. So there's an ellipse, there's an ellipse, there's an ellipse, there's an ellipse. I started out strong, ended up weak. This is what it's supposed to look like. So I'll give myself a little bit of credit on that one. I'll give myself a little bit of credit. We have our circle where it needs to be. So if I were to take this and cover this up and go like, pew, looks pretty good. Pew, pew. So that's my ellipse. Identify the center vertices and co-vertices of this guy here. All right, well, first things first, it's not a parabola. It's not a circle. Why isn't it a circle? Because there's a number in front of y squared and not a number in front of x squared. So is this an ellipse? Yes. Why? Because both of these are positive. If one of these were negative, then it's something else. You'll find out in the near future of what that something else could be. Now, when I did a problem like this with a circle, the thing that I did first is I grouped everything up by variable, and then I ended up completing the squared, and I'm going to do the same exact thing here. So I'm grouping the x's, leaving some space, grouping the y's, leaving some space, and that's going to, while I'm at it, by the way, let's subtract 225. And there you go. Okay. Before I go any further, before I tarry further, let's do this. In order for me to do completing the square, I really want nothing in front of y squared. So let's rewrite this out, and let's factor out a 9 so we can, for the moment, pretend that there's nothing in front of y squared. So this becomes negative 10y, leave some space, set that equal to negative 225. Okay, the part here in purple, not so bad. I'm going to add 9. Y, half of 6 is 3. 3 squared is 9. Got to do the same thing over here. I'm going to take half of negative 10, which is negative 5, square that and make it 25. Now this is where you have to be careful. I'm not going to add 25 to both sides. Technically on the left here, 25 lives inside of a parentheses that's being multiplied to 9. So if I'm going to add something to both sides, I'm adding 9 groups of 25, which is 225. Okay? Tricky. Tricky, tricky, tricky. But what that leaves me with is x plus 3 squared plus 9 parentheses y minus 5 squared equals 9. Now, if it's an ellipse, I have to make this equal to 1, so let's divide everything by 9, and ooh, God is good, look at that, over 9, and my standard form is now coming together. X plus 3 squared over 9 plus y minus 5 squared, I'll put over 1 even though it's not necessary, is going to equal 1. Now, for an ellipse where the number underneath the x is bigger than the number underneath the y, I have this form right here that I'm going to write up. It's going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. My center is going to be hk. So if negative h is equal to negative 3, then h is going to equal positive 3. And if negative k is equal to negative 5, negative h is equal to positive 3, so h is negative 3. That changes a whole lot if I don't do that. Negative k is equal to negative 5, which means k is 5. There's my center. My vertices are given to me by the formula h plus or minus a, k. A is the square root of 9, which is 3. So my vertices are going to be h plus 3 or negative 3 plus 3, k doesn't change. And my other vertex is going to be h minus 3 or negative 3 minus 3, which is negative 6, 5. Those are my vertices. My co-vertices are given by the formula h, k plus or minus b. We already know what h and k are. B is going to be the square root of 1 which is 1. So my vertices are going to be h, which is, what was it? Negative 3. My k is 5, so 5 plus 1 is 6. And negative 3, 5 minus 1 is 4. Not graphing this one, kind of ran out of space. But if we had to graph it, we'd be able to, and you can watch a video on how to do so if you're dying to know. Use the information provided to write the standard form equation of an ellipse where I have 2 vertices and 2 foci. This is what I notice. In my vertices, the y values don't change, which means I have a horizontal major axis which has an equation that looks like this. These are the ones that are wider than they are taller. Okay, so I'm going to write that out. Y minus k squared over b squared equals 1. My center is HK. I don't have a center here, so I can't really start with that. So let's go to vertices. Vertices are given to us by H plus or minus A and K. So that at least gives me a K of 9. Okay. Do I have an A? No. But this is what I also know. Foci are given by the equation H plus or minus C K. So if my foci here are going to be 5 plus stuff and 5 minus stuff, well then that 5 is going to be my H. Also, plus 2 root 7 minus 2 root 7 tells me that C is 2 root 7. With that information, if my vertices were given to me by H plus or minus A, then since this has a difference of 16 between each other, that tells me that A is 8. Okay, so then that's because my horizontal major axis is going to be 16, and your half of that is going to be divided by 2. And so that right here tells me that A is 8. Now, do I have all the information that I need? I do not, because I don't know what B is yet. I have A, I have C. Well, what we do know is I can find B, and it's not too bad. So C squared equals A squared minus B squared. C is 2 root 7, so 2 root 7 squared equals A, which is 8, so 8 squared minus B squared, which is, I don't know. 2 root 7 times 2 root 7 is going to be 4 times regular 7, which is 28. This becomes 64. That equals B minus B squared. Move that up here. Subtract 64 from both sides, and that gives us negative 36 is going to equal to negative B squared. Make them both positive. 36 equals B squared implies that if I square root everything, B is 6. So now I have everything that I need to plug this in here and make myself happy. So just to save some space, do I have any negatives that I have to deal with? No. So x minus h is going to be x minus 5 squared over a squared, which is going to be 64, plus y minus k is 9 squared over b squared, which is going to be 36, equals 1. And that is my ellipse, total ellipse of the heart. It's a song. It's great. I believe that's a Journey, but I could be wrong. Identify the vertices, foci, and asymptotes, and then sketch the graph. This is a hyperbola because we have a y something squared, we have an x something squared, we have a minus in between, and it equals 1. Usually hyperbola look like that, and that's no hyperbole. English humor. Since the y squared is positive and the x squared is negative, we're going to compare it to this function right here because it's a vertical transverse axis. So we're going to compare it to y minus k squared over a squared minus x minus h squared over b squared equals 1. The center is HK as usual, but oh friends, be careful. H is over here, not over here. So negative H is in this case negative 3, which means H is regular 3. Tricky, tricky, tricky. And negative K is positive 4, so regular K is negative 4. All right, be careful. It's very easy to flip those guys around and get it backwards. Let's do the focus next. So in order to do the focus, you need a C, and we don't have a C. But the way you would find C for hyperbola is you would do C squared equals A squared plus B squared. So if you remember ellipses, it was minus, now it's plus. So what do I know? I know that C squared is 1 plus 1, which means C is the square root of 2. So the foci is found by doing h, which I already know, k plus or minus c, which is what I just found. The h is 3. The k is negative 4 plus or minus root 2, so I'll do negative 4 plus root 2, and then 3, negative 4 minus root 2. Okay, that's my foci. My vertices are going to be h, k, plus or minus a. So 3, once again, k is negative 4. If a squared is 1, then a is 1. So negative 4 plus or minus 1, which I'll do negative 5. Because that's negative 4 minus 1. And negative 4 plus 1 is a negative 3. Now the asymptotes, and I'm kind of running out of space, so let me, I don't need this information. I don't think I need this information that much anymore. Maybe I will regret this, but I don't think I will. The asymptotes are found in this case by using, basically we're going to use the old traditional slope or point slope form, right? Because an asymptote is a line, and in this case we're going to have two asymptotes. All right, y minus y sub 1 in our case is the same thing as saying y, like y minus k. M in our case with this type of hyperbola is going to be positive a over b, which I know them are both, them, I know they are both 1. And then I have x minus h. Okay? So my asymptotes are going to be two functions. And let me do this. Let me do y minus k is going to be the same as double negative y plus 4 from that equals negative or positive or negative plus or minus 1 x minus 3, which makes this y plus 4 equals a positive x plus minus 3. And a negative x minus 3. And just because time is an issue, if I were to simplify that, subtract 4, do a little distributive property, I have two equations, y equals negative x minus 1, and y equals regular x minus 7. So this is all the information I need. I'm not even going to try to graph this. So let me just pull it off the internet, pull it off Desmos when I graphed it myself on Desmos, and that's what you're going to end up with. Okay, you could see, like, for example, one of the horizontal asymptotes is going to cut through here. The other one's going to cut through here. My vertices are where they need to be: 3, -5, 3, -3. It's hard to see the foci. The center is 3, -4. So, everything is where it needs to be. And again, if you're looking at the asymptote as positive x going through 7, you can kind of see the asymptote take place. All right? Graphing these guys aren't fun. Not at all. But we did it, and I'm proud of us. Use the information provided to write the standard form equation of the hyperbola. Well, looking at these guys, my y values are the same, so we're going to use this formula right here. X minus h squared over a squared minus y minus k squared over b squared. That's going to equal 1. Okay, what do I know? Well, what I know is vertices are usually given to us by the equation h plus or minus a, and then k, which tells us that k is -2. Okay, I have 7 and 5. Those are 2 apart. So if I were to take 6 and add 1 and take 6 and subtract 1, that tells me that 6 is h and a is 1. So h is going to be 6, a is going to be 1, bada bing. Now I need b. I know that like in an equation like this and a hyperbola like that, my slope is going to be in the form plus or minus b over a. My slope for these guys are 11 and -11. So my slope, b over a, is the same as 11. Well, I know that a is 1. So if a is 1, b is 11. So I have all the information that I need to plug this guy in here. X minus h is x minus 6 squared over a squared. A is 1, so over 1. So technically I don't need the over 1, but I committed, too late. Y minus k is going to be y minus -2, so we'll put y plus 2 squared over b squared. B is 11, so 11 squared is 121, and that's going to equal 1. And that's my guy, baby. That's my guy, baby. Dunzo.